So thank you for joining us today for this ABN Technical Series webinar. This is today's webinar is presented in partnership with Barth Haas. So we're joined today by Lennart, who is the Brewmaster at the Barth Haas new campus in Beijing. And he's going to be talking today about one of the hot topics in brewing at the moment, which is biotransformation. And as usual, he'll be presenting for about 20 minutes, which will be recorded, and that will go onto our YouTube channel. After his presentation, we'll then be open for a live Q&A session for anybody who's listening live to the presentation. We'll have about a 25-minute Q&A for Lennart to answer any of your questions. So I'm going to hand you over to Lennart now. Lennart, thank you very much for joining us today, and I'm going to hand the controls over to you.
Just a moment, I'm starting to share my screen now. So you should now see the presentation mode, isn't it?
Yep, we can see that now.
Oh. All right, then I will start my presentation now. So hello again from my side. Thanks, Charles, for letting me be here. And today I'm going to present you a webinar about, Charles already mentioned, a very hot topic at the moment, biotransformation. And yes, I call this presentation Hops and Yeast, the Magic Team. So let's jump in. So first of all, there are more than, I know more than about 220 commercial available hop varieties at the moment, and so worldwide. And on the other hand, there are at least the same number of yeasts, or I would say Saccharomyces yeast strains, and if you including non-Saccharomyces yeast strains and let's say bacteria, you get more than a trillions of possible combinations of for brewing experiments and all these kind of stuff. So it's got a huge potential, and I would like to first start with talking about the partners with the yeast, and right afterwards I would jump over to the hop topic, and afterwards I would like to give you some possible adjustments or what you can adjust about the process for enhancing the bioflavoring in your beer. All right, so first of all, I brought you just a simple table of aroma compounds, which you probably all aware of, but it's just for soft start, I would say. So the yeast can produce different kinds of aroma compounds, and they're basically grouped into groups. So first of all, the green beer bouquets, and on the other hand, the aromatic compounds. And yes, like as you all know, or you think, or you probably know, that the green beer bouquet compounds like the diacetyl and acetaldehyde are just flavor compounds that you want to get rid of. Besides, if you're trying to producing a Turkish Pilsner, maybe there's some diacetyl could be improving the mouthfeel, but normally you like to avoid them or get rid of them in your fermentation. And on the other hand, you got the aromatic compounds produced by the yeast, like the isoamyl acetate, which is pretty well known in the German wheat beer production. And on the other hand, the 4VG is more the phenolic style, which I would probably say it's more based or regular for the American wheat beer style. Right. And now I brought you another slide, which with some monoterpene alcohols, so with anerol, alpha-terpinol, linalool, beta-citronol, and geraniol, what you probably all know also, and you probably link them, or would you more link them to hops. And this is a graph of the scientific research from a former colleague in Haselbeck of mine, and they produced a word without any, as you can see on the left side of the graph, they got not any of these monoterpene alcohols in it. And additionally, they don't use any kind of hops in this wort. And after the fermentation with these 6 different yeasts, so the first one, the TIM 68, is a classic wheat ale strain. The 506 and 511 are ale yeast strains. The last 3 of them are lager yeast. And all of them are capable of producing these monoterpene alcohols, which are flavor-wise described or recognized as I show you. You can see on the right side of the slide, like a lemon, lime, orange, or ginger style flavor, or some floral like delilac. And yeah, this is pretty interesting, I would say. And of course, you can see the concentration rate is not that high because it's for the and the TUM 68 is about just 7 micrograms per liter. But to keep in mind, there's some possible synergistic and additive reactions, which I will go in detail later on. So it could be could have an impact on the flavor aroma of your beer. And on the other hand, your yeast is not only capable of producing some aroma compounds, it's also capable of reducing or transforming, converting some of your aroma compounds, like the sorry. It's also scientific research from Kabine Haselbeck, a former colleague of mine. They did several batches with different original gravities, so 7, 12, and 18 Plato, and they used 2 types of yeast. So the TUM 506 is an ale yeast, and the 193 is the lager yeast. And as you can see, based on the yeast strain and also on the original gravity, you can have a huge decrease in the content of geraniol, at least as shown in this trials. It could be more than 80%, which is pretty much, because the final, so they did the same as the trials before. They just dosed in 70 micrograms per liter and looked up for the transformation or conversion rates of this aroma compound. And why geraniol is that important, I would like to show you on the sorry. I would I'm sorry. Sorry, excuse me. I've got a little cold, so my voice is a bit bad. Geraniol is very important for citrusy flavor, as you can see on the right graph. If you're only dosing in like 10 micrograms per liter of geraniol into a lager beer, you result in a higher fruity, citrusy, and floral aromas. And on the other hand, oh Mann, meine Stimme. Please excuse this. And if you just increasing the geraniol content about 40 micrograms per liters, you will have more fruity and citrusy and floral notes, which is very important. So it's the proof that geraniol is important for the flavor, citrusy flavor of a beer. Oh man. Okay, but so let's move on. I'm sorry. Now we're heading in the direction of the hops. On the right side of the slide, you can see some esters and esters, and especially the acetyl 2-methyl butanoate. And this flavor compound originates from hops and can be transformed by the yeast. On the other hand, you can find this compound compound in fruits like pineapple, mango, orange, plum, and raspberries, and all kinds of these higher esters and higher alcohols produced by the yeast are considered to have a boosting effect on the overall hoppy flavor of your beer via some synergistic and additive effects, as I mentioned before. And when we are talking about the synergistic effects, it's about that it means that the effect of the combination of two compounds together are higher in the sum compared to the sum of the separate effects. So if it's just below the threshold and you adding in the same another compound, you can reach a threshold. Besides, it's not reaching below the threshold. I need to get another sip of water. Sorry. So here again, please excuse us. My voice was good all the day, but now it's getting down. Okay, let's get back to the topic. I'm really sorry. Sorry, let me get back to. So, yeah. So synergistic and additive ways is probably should be not underestimated for enhancing your overall hoppy flavor. And now we're heading back to the biotransformation of hop-derived compounds. And as you can see, the green squares are the aromatic compounds, and on the right side, let's say purple or lightly orange squares are the reactions which are transforming these aroma compounds. So as far as I know, there are no reaction known for the monohydrocarbones like myrcene, but and for, let's say, for the discrete thermodynamics and ethers, there can be some reduction pathways for biotransformation, and for esters or esters, the hydrolysis and trans-esterification is possible. And as you can see, I marked, or there's some green arrows on the three lower ones, and this they are at the moment part of some scientific research at the moment worldwide, and will be part of the next slides on my presentation. So yeah, for the glycosidyl bound aroma compounds, it could be a breakdown by hydrolysis. The sulfur compounds is mostly cysteine conjuncted and transformed into thiols. And probably you maybe know all of them. The pathway about the monoterpene alcohols is like the reduction, translocation, or isomerization or cyclization, as shown on the right, is pretty well known so far. So it's very known that geraniol can transfer into citronellol, or in another way into linalool, and linalool again to terpineol. So as I showed you on the slides before, this is a pathway which can happen with your aroma compounds. And if you're reducing the geraniol content to, let's say, linalool, or at the end of alpha terpineol, your flavor profile will probably change from, let's say, more citrusy to more floral at the end. And if you like to suppress this transformation, it's probably a good advice to add the hops later in the process, so the yeast is not that active anymore. But I will go in detail about some process adjustments later on. So let's jump into the glycosidyl bound terpenoids, which are very hot topic at the moment. So what is a glycoside? A glycoside contains a sugar and an acetone, and for a regular sugar is the glucose, and on the other hand, the acetone is in this state of presence and not flavor active component like linalool, geraniol, alpha terpineol, or some monoterpenes or other components. And to get them into a flavor active state, they need to be transferred into, or the bound between the sugar and the alkyl cone needs to be cleavaged. And this needs to be done by the beta-glucosidase, which is an enzyme which naturally occurs in, in yeast cells. The scientific research so far is, I would say, very confirming that the contribution is not that high to flavor, but I would keep in mind the synergistic and additive effects, because only 2 to 5% of the glucosidase-bound terpenoids are converted or transferred into the active flavor state and this is because the yeast, the activity or the main part of the beta-glucosidase intracellular and extracellular, and it's not possible that these glycosides can pass the cell wall. So at least, or you can, if you trying to open up the yeast cell, but then you will result in an autolysis, and this will make some off flavors which you really don't know, which you really don't want to do. All right, so let's get to the, I would say, the very hottest topic in the brewing world about is the biotransformation process of cysteine and glutathione-bound thiols. They're basically, I would say, basically the same as mentioned before the glycose, but instead of the sugar, these kind of molecules are an alkyl cone, which is a thiol, and on the other hand, it's a cysteine or glutathione. And because of this structure difference, you will need another enzyme for breaking down this chemical bond. And for the cleavage is the beta-lyase responsible, and this enzyme can also be found in the brewing yeast. The conversion rate is basically or probably on the same level as the beta-glucosidase, but it definitely got a significant impact on our flavor on the beer, because as you can see for the thresholds on the right side for 4 MMP, 3 MNH, and 3 MHA, they're pretty low because it's just 4 nanogram per liter for 4 MHA or 60 nanograms for 3 MHA. So this is the reason why, because let's say a maximum 5% conversion rate also convert you that much aroma compounds into your beer that this except the flavor threshold. Yeah. So, and these precursors are not only found in hops, but also in the malt and barley, but definitely more in the hops, the barley, and because you're adding them probably in the fermentation, the excess is higher compared to the maybe if they're stuck in the watering process. And which is interesting, 99% of the 3 MH is found as a precursor. And on the other hand, the main part of the 4 MMP, which is probably responsible for the characteristic flavor of Citra or Nelson Sauvignon, is found in the free form, so not in the bound form. So we probably don't need any biotransformation process to result in high 4 MMP contents in your beer. And what is not shown on this slide and on the upcomings is there's another enzyme which is probably capable of some biotransformation pathways, is the exobeta-glucanase. But to be honest, I didn't find that much in scientific papers about this. But we all should keep this in mind. This is not only the beta-lyase and the beta-glucosidase which are responsible for these kind of pathways for the huge part, because it's, as I shown you before, there are many different ways of biotransformation going on in the yeast cell. But of course, beta-lyase and beta-glucosidase are promising candidates for high activity for the flavor, or changing the flavor. And so let's move on to the adjustment, or how to adjust to achieve higher levels. First of all, of course, the yeast strain. Saccharomyces yeast strain definitely have less beta-glucosidase activity and better amylase activities compared to non-saccharomyces yeast like the Brettanomyces. And of course, it's also found that the activity in bacteria like E. coli is higher than in Saccharomyces yeast. But of course, if not all of you want to let's say spoil your beer with a Brettanomyces yeast just for bioflavoring the biotransformation process. But yeah, it's interesting. And on the other hand, the activity is highly strain dependent. So you should watch out or maybe a combination of different yeasts and pitching in at different times could be a good way to improve the bioflavoring and biotransformation. Now, of course, this is not a new thing to all, because you're probably choosing your strains based on the aroma output, like more estry or phenolic, but we also keep in mind which compounds we're adding can be converted or transferred by a certain yeast, like the geraniol, which I showed you before, in the huge decreasing rate of nearly more than 80%. It's should be kept in mind. Secondly, the time of dosing hops also is very important, and this is what I say the scientific papers agree on, that the highest activity of beta-glucuronidase reached after 3 days of main fermentation. So if you want to get the best results for this kind of pathway, you should make an active dry upping during your active fermentation. But of course, if you're adding the hops into the active fermentation, you will probably or maybe have some stripping off by the CO2 of the aroma compounds, but these aroma compounds are probably these ones who are not water soluble, so more the myrcene, which probably don't want in, as long as you, I would say, not tend to have a green, harsh flavor profile. And additionally, of course, if you're adding hops in the active the active fermentation, you will see some aroma compounds will stick onto the surface and drop out by the tube. But yeah, it's a kind of question of philosophy of the brewery and brewers, what they're aiming for. But this is you should go for the after 3 days for the beta-glucuronidase activity. And as I said before, or showed you before, that other fruits, herbs, and spices like a mango, pineapple, or coriander are capable of or consist different esters and higher alcohols, and via the synergistic and additive effects, you will reach the higher threshold, lower the threshold, and then you will have a higher impact on your flavor. All right, now we're heading more to the adjustment of the process. So the temperature of your fermentation, of course. This is nothing new, that if you're increasing the temperature, you will resolve the faster process, because you probably all know the rule of the thumb. Then when you're increasing the temperature by 10 Celsius or Kelvin, the reaction speed is doubled. But of course, you can double the extraction rate, like from 20 to 30 degrees, as long as beside this, the optimal growth rate of the Saccharomyces species is about maybe, or should be about 32. But of course, this is far too high for well-running smoothie fermentation. But I would recommend you to use higher levels for higher temperatures for higher biotransformation levels. And last but not least, of course, the choice of hops. I would recommend, of course, using some, using some flavor bombs like Citra, Mosaic, Centennial, Simcoe, Cascade, and Chinook, and especially Centennial and Chinook looks very promising. But to be honest, every kind of hop variety got a certain level of biotransformation, because the glycosides content of at least of the hop plants are at least double the number of the free aroma compounds. So and for other plants it's more than double, so some 4 times higher than the free volatile aroma compounds. It just is just basic biological reasons, because the plants storing these aroma compounds for harder times, or when the time is right of the year, for some pollination, they release these flavor compounds via some enzymes, and so the plants will live on. So this was my presentation. I hope you liked it, and please excuse my my tongue, my my speaking. Yeah, I don't know what's happened.
Thank you very much, Lennart. I'm just trying to get my video going again.
I'm stop sharing.
Yep, there we go. Okay, well, thank you very much. Thank you very much, Lennart, for that insight into biotransformation. I hope you find it useful in your brew houses. We'll stop our recording now, but we're going to move on, for those watching live, into the Q&A session.